Welcome back to our channel. My name is Teacher Smith and today we are going to do a very interesting question on counting problems. So before we start off with the session, let's see what is the importance of this topic. Now regarding the counting, we all know how to do normal counting of numbers. But in Math Olympiad, what we need is there is some systematic way of counting. If we can achieve this, if we can find out the systematic way, then counting becomes very simple. Let's try to understand what it is using the past year SASMO question. Let's have a look. So here the question says, Mia, the bee can only walk on colorful houses. How many ways can you color exactly 3 white houses with the same color so that Mia can walk from A to B? So here there's a cute little bee who is standing at position A. The position is this one. And now the bee has to go at position B at this part. Now the question is asking, we have to color 3 white houses. Now we can observe the white houses are in the middle. The 6. 1, 2, 3, 4. And then 5 and 6. We have to make sure we color the 6 white houses in such a way that if we just color 3, the bee should be able to go from A to B. And remember, the bee can only walk in colorful houses. For example, you can see A is colored and this is colored. Regarding B, this and this is also colored. So let's say the bee can freely roam around here at this part. Also, if it reaches at this stage, it can also roam freely because it's colored. So we just have to connect a bridge using 3 white houses. We have to color them. So let's take an example. Let's say if I color this one first. 1, 4 and let's say 5. Can this bee still go from A to B? Let's just see. Here, if the bee is at A, since this part is colored, this is colored and this is colored, what the bee can do, it can walk, wow, and reach at B. Also, it can walk from this part towards this colored one and then move to part B because it can walk on colored houses. Now, let's take another instance. Let's say, let me erase this part first, all of this. Now, let's say if the bee is at this position. Let's say if I color this part, let's say I color this one, and let's say I color this one. Does this satisfy? Oh, we can observe. There is still the bridge that is connected, so the bee can still walk from here. And this can be counted as one way. Wow. So, it doesn't matter the third one. There should be a bridge that connects between two and it should walk freely. Now, let's take another instance. Let's say if the bee is at this position, we have colored this part and now we have colored this too. Can the bee go from point A to point B? We can observe the bee can reach till here and it still feels lost because surrounding it there's no part that is colored. So, we should try avoid this type of situation. So, it should be surrounded with colors. Now, if I start counting, let's say, if I colored, let me choose the pen first. If I color this one, and this one. Oh, we can count this as one way. Perfect. Now, let's say, for an instance, I change another situation. That is this one. This one new as colored, this one as colored, and this one again as colored. Oh, we can see the bee still walks to B. So this is, another part of color. Oh my God, I'm sorry. It can go from here to here. Now the thing is, if I keep counting one by one, there are chances that I can miscount, I can double count, or else here if I start putting the numbers or else the ways you can see here. Let's say I color this one, let's say color this one, color this one. We can observe, it can still walk from here to here. But the diagram, the figure looks so messy. I can miscount or double count. So if I randomly start counting the colors, the 3 colors, I may not be assured that the answer that I get is accurate or not. So let's just see how we can count that the bee can travel from A to B using a systematic way. Let's try to figure this out. Now, to find out the systematic way, we can observe A is colored. This part, A is actually colored. This part, the entire part. Let me clear all this so that you can see everything clearly. Let's say the B is at part A and all this is colored. So B can roam here freely. But the next stage we can observe it's not colored. So we have to color this part. Then on the other stage also, other level, we can observe this is also not colored. So we have to color this part too. And then the last stage, that is at this part, it's also colored. So we don't have to worry about the parts that are present at the first stage and at the last stage. It's just this two stages that matters to us. So let's try to figure out how we can achieve this. So let me call this by levels. You can observe the A, the first one, I call it as the first level. The second, the purple one, I can call it as the second level. And the orange part as the third level. And lastly, the green as the fourth level. And can you tell me which two levels we have to cover? We have to just color the level 2 and level 3. Now, we have 3 colors. The question says there are 3 white houses we have to color. Now, for the 3 white houses, in the purple row, in the purple level, second level, we can see there are 3 white houses. Now, to color exactly 3 white house, from this part, we can either color 1 white house and from the next one, we have to color 2 white house. Because if you color adjacent one, then we can achieve a bridge. Wow. Now, this is not the only case. Here, we can put it as case 2. That this can be 2 and this can be 1. This means from this part, we can color exactly 2. And from the third level, we can color exactly 1. And then also we can achieve this. So here, this has been divided into 2 cases. That is case 1. And now, there is another case that is case 2. So, let's try to evaluate each one by cases. So, let's see the first case. That is, from this 2, level 2, I color just one of the block. And from level 3, I color 2 of the block. Let's see the number of ways. Let's see, from level 2, if I color this one first, we are starting from the top first. So, I want to color from level 3 also, 2 of the white houses. So, again, we'll start off from the top. So, the 2 that I'll choose is this one and this one. Now, let's just see, can the bee walk if we use this condition? Oh, we can still see, oh, it can still walk. And it can still walk. So no matter which one we choose, it can still walk. So this is just the first way. Now, keeping this part as fixed, just change this to position because this is not the only 2 case. I can also have this one. Now, you tell me, if the bee is at A, can it reach B using this case? Oh, it's not possible. The bee can reach till here and it will feel lost. So this is not the way. Now, first one and second one we have colored. Second one and third one we have colored. Is there any case that is missing? Oh, the first and the last. So let's just color the first and the last. And can the bee still walk in? Oh, we can observe the bee still can reach part B. And this is another way. So in the first case, when I have 1 color from second level and 2 colors from the third level, there are 2 of the following ways. So I'll write down 2 here. Now, this is not the only case where the first one is colored. You can observe. It's not the only case. I can also case 2-1. I can also color third one. So let's move on in the same case differently. Move down. So if this is colored, and again, we'll move from top to bottom, that is coloring this 2. Now tell me, can the bee walk? Oh, we can observe. It can still walk from this part or else it can still walk from this part. So this is the first way of going if we color this one. Now let's move down. If we color this 2. So it can still walk from this part, or else it can still walk from this one. So no matter what way we choose, it can still walk. So this is second way. Now keeping the second stage, that is second level 1 constant, let's move to color this 2. Now can the bee still walk? Yeah, we can observe here it can still walk on the colorway and still reach B. So here we have 3 of the following ways. So I'll write down 3 here. Now first one we did, second one we did, let's now move on to the third one, that is coloring this one. Now if we color here from this level 1, we have to make sure we color 2. So let's just color 2 here. Can the bee still walk? Oh, we can observe. Whoa, still walk. Whoa, still walk. So this is one way. If we color this 3, can still walk. Now let's move down, keeping the first one as same. This is it. Now can the bee will still walk? Oh, we can observe can still walk. So this is another way. Now keeping the first one as same, 1 and 3, let's see. Oh, the bees can still walk. So here there are 3 ways here. So I can write down 3 of the following ways. So in the first case, that is the case 1, the values that we got is 2, 3 and 3. Now, how to find out the total number of ways here? So 2 way, 3 way, 3. The total number of ways we just have to add. So if we add, what is the answer? Wow, you are so fast, which is nothing but 8. So in the first case, where we have this is the 1 color and the third level as 2 colored, we got this as the answer. Now, do you remember we still have one case left? That is this, the second level, we color 2 and the third level, we can color 1. And in this way, we can achieve 3 white houses. So let's just see. Remember, from which position should we start? Should we start randomly or from top? Oh, from top, in an order. So here, if I color this 2 from the first level 2 and 1 from level 3. Now 2 from level 2 can be quite challenging. So that is the reason why I have colored 1 from level 3 first. Because I know this can be fixed. So if this one can be fixed now, let's see from level 2, which 2 we can color. Also remember from top. So let's say if I color this 2. Can the bee still walk in? Let's see. What? We can achieve. What? We can still achieve. So this is just one way. Now, keeping the third one as fixed. This part. Let's move on to the another case. That is coloring this 2. Yeah, and we all can agree that here we can still achieve. So this is another way. Now, keeping the third one as the same. Oh, let's move to the other case. Can we still walk? Yes, we can. So here we can observe there are 3 of the following cases. So I'll write down 3 here. Now from the third one, we have tried all the 3 ways. Now let's move on to the next one, that is coloring this part. So if I color this one first and remember from top in an order. So can the bee still walk? Of course it can still. So here this is one way. Now keeping the third one, that is this one as constant, let's color other 2. We all can agree it can still walk. There is a bridge. Another way. And the last one, that is this one. Can it still walk? Yes, it can from this way. So here there are 3 of the following ways again. So I'll write down 3 here. So we have tried this one, tried this one. Is there any other way in coloring the third level? Of course, the last one, very good observation. We are developing a pattern you are not realizing. So here we can observe. We again have to start in an order. So here, if I color this 2, can the bee still walk? Ooh, we can observe the bee can reach till here and there's no bridge. It will feel lost. So this is not the way. So keeping this one as constant, let's try another one. Oh, can the bee still walk? Of course it can still walk. So here this is our first way. Now keeping this one as constant, let's see. Here, can the bee still walk? Yes, we can achieve this from moving here. So here, if we try out these cases, there are 2 ways. And if you try, there's no other ways. Because we have explored all 3 from here and all 3. So I'll write down just 2. And now, How to find out the total number of ways? Which sign should I put in the middle? Of course, the plus sign. And now if we add it, can you tell me? Again, it's the same answer. That is nothing but 8. So here, from the first case, that is case 1, and the other case, that is case 2, we have got in case 1 the answer is 8 way, case 2 is answer 8 ways. So, how to achieve the total number of ways? What we should do? Yes, just add them up together. 8 plus 8 is nothing but 16. So here, 16 is our final answer. So, what we can understand from this question? First of all, whenever this question based on counting and you try to count randomly, you can observe, you can miscount, you can double count. So if you face any of the challenge, something like this, one thing you can do is you can set some rules for yourself. For instance, here the rule that we set is we can count one by one and in an order, making sure that there is a bridge every time we do. So the purpose, the thinking process is the bridge. Now, after we set the rule, then we have to do it in an order. And if it's too challenging, divide it into number of cases. So here, if I summarize this, it can be the summary. That is, do it in order in a systematic way. Now, you might be wondering here, the numbers 2, 3, 3 gives us 8 and 3, 3, 2. You can see there is a relation between numbers 2, 3, 3 and the same thing 3, 3, 2. So, actually, you don't have to do it 2 times. That is case 1 and case 2. Let's see how we can achieve this using just case 1. You can observe it's 2, 3 and 3. The reason? Because the diagram looks like this. But in the other case, we move from A to B. But if you look closely, pay attention here. The diagram is actually symmetric. It follows a rotation symmetry. This means here, instead of A, if I write down B, instead of B, if I write down A, the diagram still looks the same. So either if you evaluate case 1, it's the same numbers. If you do it reverse, still feels the same. That is the reason why it starts with 3, 3, and the last one, here it's first one, here it's last one as 2, because the diagram is the same. So here, what we can understand, set some rules, do it in cases and in an order, the systematic way. So here, if I want to summarize, I can summarize like this. Now, here, if you observe, the part that we have followed to find out the order is, I can name this as M and P and I can name them as X, Y, and Z. So what we can do is select 1 from M and 2 from X, Y. Then keeping the M same, we can choose X and Z. Keeping the M same, we can choose Y and Z. So this is how we can proceed. Then we can move on to N and the step remains the same. X, Y first, Y, Z later and X, Z later. Then P, then X, Y first, X, Z later and Y, Z later. And this is what I am telling you regarding the order. You can start off from the top, divide it into cases and just follow an order. So the summary is, convert the question into operation and set of rules and then solve it in an order. This is a thinking process for counting problems. Now, if you have understood this question very well, here, it's a small challenge for you. The question, you can take a pause. You can pause the video, read the question, try to do it. And if you are able to get it correct, you can send me your answer in this group. This is P1, P3 study group. You can post your answer or else in the comment section of this YouTube video and I'll help you check it. But if you are unable to solve it, it's very okay. It's a very challenging question. You can ask me in this group. So, I'm Teacher Smith signing off right now, but I'll see you in the next video.